Hello, everyone. This is the video that is going over what we did today, Tuesday, August. It has been a long year already, October 6, 2020. Our content language, students will expand upon and apply their knowledge of triangle congruence to triangle similarity in writing by answering questions using guided reading notes. So first of all, we had a few practice problems happening. Are the two triangles in the figure at the right congruent? And if so, which theorem can we use to prove it? So I can tell right away that these triangles are not congruent because these corresponding sides 5 and 4 have different lengths, and in congruent triangles, all of the sides must be the same length. The congruent triangles are exactly the same size. So these are not congruent. And you can also, or you could also use the sign for congruency, which is an equal sign and a tilde. And you could put like a line through it. Although I guess if you're typing it up, that is probably a little bit harder. Below, we have two triangles that share this side. So they have that side in common. We also know that these two side lengths are parallel, which means not only is this angle the same, but actually it might not. Let me think for a second. We have, they are parallel. Do we have any other? Do we have like an alternate? Oh yeah, this angle, there we go, you guys, I see it. This angle and this angle are alternate interior angles. Like if I drew this line out, okay, and pretended those other lines weren't there. So we have, oh, we have ASA. Oh, we have a side. Let me change this to a highlighter. We have a side, an angle. Oh no, we have saw. We have side, angle, or you can call it angle, side. It's not ASA, it's not angle, side, angle, because the side would have to be in between the two angles that are the same, and that is not the case. Okay. And then down here's interesting because we have two right triangles, and what we're going to do, we know that they have this corresponding side that's the same, which is the hypotenuse. And we knew if we had another side length that was the same, we could use hypotenuse and length, or if we knew all of the sides were the same, we could use side, side, side. So luckily, we know that we can find the third side of a right triangle by using the Pythagorean theorem. So I don't know the shortest side, so let's call that, well, let's just use A, since that's how you guys know the Pythagorean theorem. So I don't know the shortest side, so I'm going to call it A squared, plus the other leg, which is 12 squared, is going to be equal to 13 squared. So let's solve this. A squared, 12 squared is 144, equals 13 squared is 169. And then we're going to subtract 144 from both sides. And we're going to get A squared is equal to, let's see, 9 minus 4 is 5, 2, just 25. Then we've got to take the square root of both sides. And we get A is equal to 5. Now, when you take the square root of both sides, you're normally going to get positive and negative 5. But when we're dealing with triangles, we only need the positive because we're dealing with the length. So that means this side is 5. And since this side is 5 and 13, and we have 5 and 13 there, we can tell by hypotenuse length, Or obviously, if it's 13 and 5 here, this side has to be 12. So that could be side, side, side. What else are we doing? Okay, so you need, if you haven't done this yet, you need to watch this video. It is my favorite, Sal Khan. Love him. And he's going over an introduction to similar triangles. As you're watching it, you will need to be stopping and answering these questions. And then your exit ticket, how are similar triangles and congruent triangles the same? How are they different? And then today, new independent work was 4 practice problems on Khan Academy at that link, finding similar triangles. And I'm also just keeping everything else that we have been assigning as independent work, so you know if you have finished everything. Please let me know if you have any questions.